Myself, Shobha Mengane, Department of Physics, S.V.K.T. College, Devali Camp. Today's lecture is SYPC Physics Paper 2nd, Electronics, and topic name is Operational Amplifier. In last lecture, we have seen construction and operation of UJT, equivalent circuit of UJT and characteristic of UJT, and application of UJT as a relaxation oscillator. Session agenda. Today we will see introduction to op-amp, circuit notation of op-amp, operation of operational amplifier, parameters of op-amp, ideal op-amp, golden rules for negative feedback, and concept of virtual ground, and limitations of real op-amp. Learning objectives, circuit notation and operation of op-amp, parameters of op-amp, ideal operational amplifier, pin diagram of IC 741, and limitations of real op-amp. Operational amplifier. Now first we will see what is the requirement of operational amplifier. In many circuits or medical instruments, we require amplify the signal because transducer or other instruments are having very low output voltage in microvolts or millivolts, and therefore to amplify this we require the high gain amplifiers, and generally operational amplifiers are used for this. And we can define operational amplifier as DC coupled high gain electronic voltage amplifier with differential inputs and usually single output. Means it is having two inputs and one output, and input is the difference between two the input is differential input, means it is the difference between voltages at the two inputs of the operational amplifier. Now we will see the circuit notation. This is the symbol of operational amplifier. There is a negative sign is there, that is called as inverting in terminal, or that voltage connected to this is called as a Vn. The plus sign shows that it is a non-inverting input, and here it is shown by Vp. The voltage at the connected terminal at this terminal is Vp, and there is single output, that is we have shown as the output. Now Vs plus and Vs minus. These are the biasing to the operational amplifier. There is Vs plus means power positive power supply, and Vs minus means negative power supply. In this case, here we use the Vs plus and Vs minus. We can use plus Vc and minus Vc also. And voltage for operational amplifier is generally plus or minus 18 volt. Means Vs plus is plus 18, maximum voltage is that, and Vs minus is minus 18. But generally in practical we use plus 15, minus 15, or we can use from minus plus minus 12 also. Operation of op-amp. Now in this case we have seen the two inputs, inverting and non-inverting. For non-inverting input voltage is Vp, and for inverting input voltage is Vn, and therefore differential input voltage is Vp minus Vn. Now if gain is here low, if feedback is not used, feedback means here part of output is given to the input, that is called as a feedback, and there are two types of feedbacks, positive and negative. Generally for operational amplifier, when we use the amplifier, we use the negative feedback, and when the feedback fraction is 0, in that case gain will be open loop gain, and if this open loop gain is equal to A, then we can write output voltage in terms of input voltage, and that is V out is equal to gain times the differential input voltage, that is we can write V out is equal to Vp minus Vn into A. Now parameters of op-amp. Before seeing parameters of op-amp, why this operational amplifier is called as an operational amplifier? Now in this case, in this amplifier, the many of mathematical operations can be done, that is addition, subtraction, multiplication, division, logarithm, anti-logarithm, etc. can be done by in this case. Now, and therefore, it is called as a operational amplifier, and they are used in analog computers. This is the circuit diagram for parameters. Now, here there are inverting, this is the inverting input, this is inverting input, and this is a non-inverting input. Voltage connected to non-inverting input is V1, and it may be AC or DC. Voltage connected to inverting input is V2, will be AC or DC. We can connect any type here, and here is the output voltage V. Now, when we connect here V1 and V2, and if V1 and V2 are equal, then output VO must be 0. But as the operational amplifier is made by some stages, and the input stage of the operational amplifier is differential amplifier, and differential amplifier is made up of two transistors, means two inputs are connected to transistor. There may be some mismatching between the transistors, and due to this, though V1 and V2 are equal, but output will never 0, but it may be some finite value. It is very small, but there is some finite value, and therefore, to get a 0 voltage at the output, we have to adjust V1 and V2 such that output is 0, and therefore, we can say that input offset voltage, it is the voltage applied between inputs, that is at non-inverting and inverting input, such that output is equal to 0, and therefore, VIO is difference between V1 and V2. It may be positive or negative, but for this positive or negative voltage or VIO, output will be 0. The next is parameter is input offset current. Now, for input offset current, that is IIO. Here we have shown I1 and I2. Here this is the current I1 and I2. Now, IIO is equal to mod of I1 minus I2, means we adjust, when we adjust V1 and V2, then means we adjust I1 and I2 such that output is equal to 0, and therefore, input offset current is IO is equal to mod of I1 minus I2 for VO is equal to 0. Now, next is input bias current, that is IB, and IB is average of I1 plus I2 or I1 and I2, and means here this is current I1, this is current I2, and IB is equal to I1 plus I2 by 2. This it is average of I1 and I2 biasing current. This is the input bias current. Input offset current drift. Input offset current drift is defined as, it is a ratio of change in input offset voltage to the change in temperature, and mathematically we can show like this. This is input offset current, that is input offset current drift is equal to delta IIO. There is difference value of IIO at one temperature, value of IIO at second next another temperature, and therefore it is delta IO upon delta T. The remaining parameters of op amp, that is input offset voltage drift, and it is a ratio of change in input offset voltage to the change in temperature, and we can write that is delta VIO upon delta T. The next is open loop gain, and open loop gain is defined as, it is a ratio of output voltage to differential input voltage without feedback, and mathematically it is open loop gain is equal to output voltage upon differential input voltage without feedback. Then next is closed loop gain. Closed loop gain is ratio of output voltage to differential input voltage with feedback. Here, by use of this feedback, closed loop gain decreases in case of negative feedback, and in case of positive feedback it increases. Parameters of op amp remaining. Input impedance, it is a ratio of input complex voltage to input complex current, and mathematically it is input complex voltage divided by input complex current. Now, input voltage range. Before input voltage range, we have to consider about common mode. For common mode means when same voltages are connected to same source is connected to both the inputs, inverting and non-inverting input, then you can say that there is a common mode of the operational amplifier. And input voltage range is the voltage that can be applied when there is a common mode. Output must be 0 because in V1 is equal to V2. But here means output must be 0. Here input voltage range means whatever the voltage we can apply at the common mode without disturbing the operation of op amp, and that is input voltage range. Now, common mode rejection ratio, and common mode rejection ratio is defined as ratio of differential mode gain to common mode gain, where AD is the differential mode gain, ACM is the common mode gain, and therefore CMRR is equal to AD upon ACM. But what is ACM is equal to VOCM upon VCM, where VOCM is output common mode voltage and VCM is input common mode voltage. And in this case here, as V1 is equal to V2, then VOCM must be 0 and therefore ACM is 0, and CMRR means in CMRR relation AD is equal upon ACM, ACM is equal to 0 and therefore CMRR is infinity in ideal case, and practically it is having very high value. Now, next parameters are slew rate. Slew rate is ability of op amp to handle varying signal, or it is the ratio of output voltage with feedback under large signal conditions. Now, output impedance. Output impedance is the impedance measured between output terminal and the ground. We have seen the input impedance. Input impedance is in between two terminals of the inputs, but output impedance is measured between the output terminal and ground. Then power supply rejection ratio. This is also shorted or we abbreviated as PSRR. This is change in input offset voltage to the change in one voltage of the power supply, provided that all remaining power supply voltages are constant. Means we are applying number of power supplies to the circuit for the input for the Vs plus and Vs minus. Out of this, we have to change only one power voltage of the power supply, and due to this change in input offset voltage, and this change in input offset voltage for a change in power supply is called as PSRR, that is power supply rejection ratio. Now we have to go for ideal operational amplifier. Here are the diagrams for standard op amp and ideal op amp. In ideal op amp, on the right hand side we have seen, we can show that here there is a negative and positive, means inverting and non-inverting inputs. Vn is the voltage at the inverting input, Vp is the voltage at non-inverting input, and in between these two there is no any connection, which shows that there is an input impedance is very high. It is infinity in ideal case. Practically in standard op amp we can say that the R in is there, but it is having very high value. Here in ideal op amp we can see out the AVI, that is whatever the input in the differential input voltage will be amplified, and A is the gain, then output will be VO will be A into VI. Vn or Vd or differential input, means we can call this Vn or Vd also, whatever that. We can use any symbol in this case. But there is a difference between ideal op amp and standard or real op amp. In ideal op amp, R out is not shown because output impedance is 0 for ideal operational amplifier. Practically, or in standard or real op amp, here we have shown R out, but this value is very small. And because of this here, In ideal op amp there is no loading effect. In standard it may be loading effect in that case. This is a comparison between ideal and standard or real op amp. Now properties of ideal operational amplifier. First is infinite open loop gain. Ideally, the open loop gain of this amplifier is infinity, very high value, and therefore we have to means for very small at the input voltage, output voltage will be high. Then infinite bandwidth. If we plot the graph of gain versus logarithm of frequency, in that case we get a frequency response curve, and for operational amplifier frequency response curve will be finite, will be flat. Infinite input impedance, we have seen in the diagram, that is there is no any connection between positive or inverting and non-inverting inputs, and means in between these two there is a infinite input impedance, means Ri is equal to infinity in ideal operational amplifier. Zero input current, as there is no any connection between inverting and non-inverting, the current cannot be passed through this, and therefore input current is zero. Zero input offset voltage, we have seen input offset voltage is the voltage between difference between the voltages connected to the inverting and non-inverting inputs, and difference of this voltage to that is called as a VIO, and this VIO is equal to 0, means for this value here output voltage will be remain 0, means 0 input offset voltage means there is a good matching at the input terminals. Then infinite slew rate, we have seen slew rate is the ability to handle a varying signal, and it is slew rate is infinite, means it can handle the varying signals. Zero output impedance. Output impedance is 0, therefore there is no loading effect in case of operational amplifier. Zero noise. Noise means here unwanted voltage or stray voltage will be there, and there is no any unwanted voltage in case of operational amplifier, and therefore property is zero noise. Now infinite common mode rejection ratio, we have seen the common mode rejection ratio is AD upon ACM. It is equal to AD upon ACM. ACM is equal to 0, and therefore CMRR is infinity. Then infinite power supply rejection ratio. Power supply means though here when there is change in one of the power supply, there is change in input offset voltage, and this is infinite in case of ideal operational amplifiers. Now Golden's rules for negative feedback. When we use the operational amplifier to control the operational gain of operational amplifier, we use the negative feedback, and there are golden rules for that. Means how we can apply. First is that no current will flow to the inputs, because as Ri is equal to infinity, the current will not flow to the inputs. And second is that the input voltages at two terminals will be nearly equal, means Vp is equal to Vn for the negative feedback. This is a pin diagram for IC741. When we use a operational amplifier, the IC741 is operational IC for the operational amplifier. It is 8-pin well package IC. For this here, there are 8 terminals are there. Pin number 7 is plus VCC or VS plus or V plus. Pin number 4 is V minus or VS minus or minus VCC. We use 1 and 5 for offset null, means to adjust the offset. We use pin number 1 and 5. In between pin 1 and 5, you use the fix of the potentiometer, and variable is connected to pin number 4. And by adjusting this potentiometer, we can have a 0 output. Pin number 2 and 3 are inverting and non-inverting inputs pin number 2 is inverting, and pin number 3 is non-inverting input, and pin number 6 is the output, and pin number 8 is a dummy connection, it is not connected, and therefore it is shown as a NC. Concept of virtual ground. What is by virtual ground? Virtual means abhasi. Here, when we connect any circuit, then we connect one terminal to the ground. But if at any node point, if we have 0 voltage with respect to ground, it is not connected to ground, but voltage is 0, and that is called as a virtual ground. And in case of IC, when it is used in an inverting mode, we have a virtual ground is like this. Here see that in this diagram, there is a inverting and non-inverting input. Non-inverting input is connected to ground. Input is given to the input is given to the inverting input here. But we know that by the properties of ideal amplifier, Vp is equal to Vn. Means whatever the voltage at non-inverting input will be at the inverting input, and the point shown virtual ground, that is by arrow here, that red point, this is the virtual ground. If you measure voltage at this point, the voltage will be 0, but it is not connected to ground. And here this is circuit diagram for this. Now here there is difference between virtual and actual ground. Virtual ground or physical ground, real ground. In virtual ground, it is not connected to it is not physically connected to the ground, but real ground is physically connected to ground. The voltage at the virtual ground is approximately equal to 0, and voltage at real ground is accurately at 0. Another point is that we can use the actual real ground as a reference voltage, but this virtual ground is taken for our adjustments for a circuit analysis. We can use this, and here this point is called as the virtual ground because voltage is 0, because Vp is equal to Vn, or Vn is equal to Vp, that is equal to 0, but it is not connected to ground. Then limitations of real op-amp. We have seen all the properties of the ideal op-amp, but what is in a real op-amp? First point is finite gain. We have seen that for ideal op-amp, gain is infinity, but in actual practice there is a finite gain. By using the feedback, we can control the gain, and the gain is not infinity but some high value but finite value. Finite input impedance. Ideally, the input impedance is infinity, there is no any connection, there is no any leakage current in case of ideal op-amp, but in real op-amp, the input impedance is finite, and therefore, there is some current flow from inverting terminal to non-inverting terminal, because there is voltage will be, there is a resistance Ri in between Vp, in between inverting and non-inverting input. Output impedance. For ideal op-amp, output impedance is 0, but in practice or in real op-amp, output impedance is not 0, it is having very small value, and due to this there may be loading effect. Input current. Here, in case of ideal op-amp, there is no input current because it is open between inverting and non-inverting input. But in case of real op-amp, there is connection, and therefore there will be input current will be there. Input offset voltage for ideal op-amp is 0, but in case of real op-amp, it is non-zero, it is having some finite value. Common mode gain for ideal op-amp is 0, but in real op-amp it is having some value. Temperature effect. For ideal op-amp, though there is change in temperature, there is no drift in case of ideal op-amp, but in actual or real op-amp, all these parameters will affect by the temperature. Then power supply rejection. Ideally, there should not be any change due to the change in the voltage, but here, yeah, for real op amp there is a power supply rejection is there. Then assignment for you students. First one is explain input offset voltage of an ideal op amp. Define open loop gain of op amp. Explain the concept of virtual ground in operational amplifier op amp. In this lecture, we have seen what is by op amp, why op amp is required, notation, circuit notation of operational amplifier, operation of this operational amplifier, parameters of operational amplifier, the ideal op amp, its properties, then golden rules for negative feedback, concept of virtual ground. In next lecture, we'll see non-inverting and inverting amplifier, means op amp as a non-inverting and inverting amplifier, applications of op amp as an adder, op amp as a subtractor. Thank you.